Hi guys, today topic is what do all acid and bases have in common? Now first we will see for acids. What all acids have, commonly have, what means H plus ions, hydrogen ions. How means the acid is reacting with metal, what gas outcomes? Hydrogen gas outcomes. So all the acids commonly having H plus ions. So now we are going to confirm that through one activity. For that, I am taking here 100 ml beaker. In this beaker, I am placing one cork. In that cork, 2 nails are fitted with that cork. And that cork is placed in the 100 ml beaker. Now these nails are connected with 6-volt battery and a bulb, and here switch. These nails are connected with a 6-volt battery. Now I am pouring some hydrochloric acid inside the beaker. What I said, commonly acid have H plus ion. Now we are going to prove that through an activity. I am taking 100 ml beaker. In this beaker, the 2 ion nails are fitted in a cork and the cork is placed in the 100 ml beaker. The ion nails are connected with the terminator of a 6-volt battery and that is having bulb. Now I am pouring some hydrochloric acid inside this beaker. What you will see means this bulb will glow. This bulb will glow. So, glowing the bulb is showing there is a flow of current. How the current is carried? The current is carried through the H plus ion which is present in the hydrochloric acid. This acid, hydrochloric acid, is containing H plus ions. So, it will decompose into H plus and Cl minus. For example, other acid, for example, sulfuric acid. H plus SO4 2 minus. Just like it will separate. HNO3 also having H plus ion. Acetic acid also having H plus and CH3COO minus ions. So, every acid commonly containing H plus ion. These H plus ion are responsible for conducting the current. So, this one is proved by this activity. What happens to an acid or a base in a water solution? We know already acids are containing H plus ions. We are going to check that whether the acids are having this H plus ions in presence of water or in absence of water. We are going to check that. For that, I am taking one test tube. Inside the test tube, I am putting some dry sodium chloride and then I am putting some of the drops of H2SO4, sulfuric acid. And this sulfuric acid and sodium chloride is reacting with each other. Then hydrochloric acid is outcomes through in a gas formation. Dry hydrochloric gas is produced in this reaction. In this test tube, I am putting some dry sodium chloride and I am pouring some drops of sulfuric acid, and this two are reacting with each other. Then HCl gas is produced. Dry HCl gas. In the mouth of the test tube, the gas is evolving, no? Here I am keeping one dry litmus paper. Dry litmus paper, there is no color change. Then I am keeping one wet litmus paper. I am keeping one wet blue color litmus paper. Then it is turning the color into red, blue to red. So, wet litmus paper only changing the color of blue to red. So this HCl, in the presence of water only, this HCl gas is separated into H plus and Cl minus. So from this reaction, what we are understanding? That HCl is reacting with water molecule only, it is giving H3O plus Cl minus, hydronium ions, H plus ions. It is giving in presence of water only. In absence of water, this hydrogen cannot exist alone. H plus ion cannot exist alone. So in presence of water only, it is producing H plus or H3O plus, hydrogen ions or hydronium ions. Now what happens when base is reacting with water? Base is reacting with or dissolved with water. It will produce hydroxide ions, OH minus ions. As it is reacting with water, H plus ions came, and base is reacting with water, OH minus ions, hydroxide ions is outcoming. For example, sodium hydroxide is dissolving in water. What will come? Na plus OH minus. It will separate like this, Na plus ions and OH minus ions. It is producing hydroxide ions. Some other examples are KOH, potassium hydroxide is dissolving with water. Same like K plus plus, it is producing hydroxide ion, OH minus. Then magnesium hydroxide, Mg2 plus plus 2OH minus. So when base is dissolving with water, it is producing hydroxide ions like OH minus. When this acid and base reacting with each other, salt and water is producing. We know acid is reacting with water, it is producing H plus ions. Base is producing OH minus ions. When these two, acid and base, is reacting with each other, salt and water is producing. For example, acid. We know HCl, HNO3, H2SO4. So in these acids, what is common? This H plus ion, hydrogen is common. So I am taking hydrogen here. For chlorine it may be, or nitrite or sulfate. For that I am writing here X plus. Base, we know sodium hydroxide, potassium hydroxide, magnesium hydroxide. So what is common in base? Hydroxide ion is basically common in base. So I am taking here OH. Instead of the sodium, potassium, magnesium, I am writing here M. It may be anything. So here acid and base is reacting with each other. So these two is joining together and it is forming salt, plus this H and OH is joining together, so it is giving H2O, water molecule. Again I will repeat, acid we know hydrochloric acid, nitric acid, sulfuric acid. What is common in acid? Hydrogen. So H plus ions. So I am taking here H. Instead of this chlorine, nitrate, sulfate, anything will be written here. So instead of that I am writing here X plus base, sodium hydroxide, potassium hydroxide, magnesium hydroxide. What is common in base? Hydroxide ion is common. So I am writing here OH. Instead of the sodium, potassium, magnesium, I am writing just M. It may be anything. Now when acid is reacting with base, what is coming? This H and OH is joining together, H2O out comes, plus these two joining together and salt is out came. So this is an example. We are going to see about dilution. When acid or base we are taking is dissolving in water. In a beaker I am taking acid or base is dissolving in water, means what will happen? Heat will outcomes, both. These two is dissolving in water means what will outcome? Heat will outcome. For example, for an acid I am taking concentrated sulfuric acid. In a beaker I am taking water, then I am pouring some of the drops of sulfuric acid and I am mixing, constantly I am mixing. What will happen means the heat will outcomes. If you touch the beaker means you can feel it. So you have to add the concentrated sulfuric acid in a large amount of water. if you add a very small amount of water with more amount of concentrated sulfuric acid, means it produces high heat and it will be splash out, it causes burns. So the beaker is also maybe break it. So you have to add drop by drop acid to large amount of water. So this process is known as dilution of acid. Like that, for base also I am going to do. For base I am going to take sodium hydroxide pellets. Sodium hydroxide pellets, same as like in a beaker I am putting some water. Inside the beaker I am going to put sodium hydroxide pellets and I am mixing constantly. What will happen means heat should outcome. So these two is an example of exothermic reaction. In both of the reaction heat outcomes. So it is an example for exothermic reaction. So when acid or base is reacting with water, exothermic reaction is happening there. So you have to add it very carefully, otherwise the mixture will be splash out and it causes burns. So you have to take care. And this process is known as dilution of acid or base.